Hello and welcome to the DME podcast, brought to you by DME, the podcast booking platform. Whether you're a podcaster or an aspiring guest, the DME app is a perfect platform for you to get booked and manage your podcast bookings. I'm your host, Sukhay, the founder of DME, and on this podcast we'll be discussing the latest news and views in tech, the ins and outs of entrepreneurship, and even dipping our toes into the adrenaline-filled world of mixed martial arts.
We're back with another episode on AI, but this time from a whole new perspective. This week we speak to Dr James Borg, lecturer in computer science at Aston University in Birmingham. James's research focuses on the cultural and evolutionary systems in AI, digging deep into what it means to be intelligent, the philosophy of intelligence, drawing parallels between the animal and human world, and some of the misconceptions around AI. This was a seriously thought-provoking conversation with a fascinating guest, so please enjoy Dr. James Borg. Dr. James Borg, welcome to the DME podcast.
Thank you for having me.
Yeah, awesome. Thank you for agreeing to do this and giving up some of your time. I kind of was, on the podcast, we kind of delve into tech and I'm personally a bit fascinated by AI. And we've done a couple of podcasts on AI in terms of the basic technology behind it and how it works, and also some of the regulation side of it and the governance side of it. But I saw your profile and some of the work you've done, which is a completely different take. So I fully admit I didn't fully understand it at all. So I was hoping we kind of have this conversation and we could learn a little bit more about your approach to AI and computer science. So just give a bit of background to yourself, really. So how did you get into computer science as a field and your specific work into AI?
So I'm a local Birmingham kid. Went to a state school in Birmingham, but at a time when people were kind of going to university, even from kind of regular backgrounds. And so I always thought I'd go to university, but I didn't know what I wanted to do, really. Like most kids don't know what they want to do. I like computers, I like maths.
Yeah.
And during my A levels, they put on a maths day for like the younger kids. And I was there helping with it. And they had a professor in from, I don't think he was a professor at the time, but a guy called Jeremy Wyatt from the University of Birmingham come in as a roboticist to give a talk about robots. And he gave this really fascinating talk about how all the easy things for robots are the hard things for us, but all the hard things for robots are the easy things for us. So this was back in the early 2000s. So, he was talking about things like chess and how chess is complicated, but, we can get computers to do it easily. But walking is hard. Still is actually hard. We see some amazing things from people like Boston Dynamics, but it's legitimately hard to do. But, anyone who's seen a baby learn to walk, they eventually just kind of get it and it's second nature. And that fascinated me. Had this idea of, trying to get things to be like humans or even other animals is hard.
Mm.
And so I thought, well, maybe I'll look into this AI and robotics stuff and realised it kind of covered all my interests. It was computers and maths, but a little bit of philosophy, a little bit of social science, a bit of psychology, a bit of cognitive science. And I thought, a bit of biology. I thought, well, okay, this sounds cool. And so I decided to apply to university to do a degree in AI. And this was before really there were many degrees in AI.
Yeah, so I think I'm probably talking about 15, 20 years ago, maybe. I don't know, give away your age.
Yeah, no, early 2000s was when early to late, 2000s was when I went to university.
So AI was a thing before OpenAI, before ChatGPT, I take it.
Yeah, it's been a thing since, AI is as old as computer science, a topic area, depending on when you consider computer science been invented. But, modern computer science starts really with Turing. Though obviously there's a lot of people before Alan Turing could do lots of really significant stuff. But Alan Turing's really kind of that starting point where you could argue before Alan Turing, there's lots of people you could argue started computer science. But after Alan Turing, you couldn't argue that you were starting computer science. It had already been started. That was the point.
Yeah.
And at the same time, he was also writing about AI. At the same time, there were two sides of the same coin. You're building a computational brain is what he was trying to do. And so it's been around since the 50s, but there's been a series of AI summers and AI winters ever since the 40s and 50s.
Yeah.
And when I went to university, we were just coming out of what they called an AI winter, which was when basically everything wasn't working. AI, all the promise of AI had fallen apart. It was a bit of a niche thing and it was starting to get popular again. mainly because we'd had the web boom, and so everyone was really into tech again. So people started getting interested in it again. So I suppose I'm at the start of, I was learning about it at the start of what we now have as kind of this ultimate AI summer. So I was at the bottom of the slope, and we're kind of towards the top of the slope with AI now. So.
Yeah, well, that's an interesting perspective, actually. I did see a chat yesterday. I think it's one of these TikTok videos and people just commenting. I think they asked, I think he was alluding to being Mark Andreessen's, from a computer history perspective, if AI was the internet, where are we today? And the answer that came back was about 1996.
Yes, absolutely. We are absolutely where we are.
Yeah, so I thought it was quite fascinating. I thought, oh, okay. And the question they asked was, well, if you knew what you knew now about the internet in 1996, what would you do? So I was like, alarm bells kind of ringing up and kind of get your creative juices flowing out of the potential of AI and what impact it can have on kind of society. And that's kind of leads me into the next question. But obviously, you've taken a different approach. Obviously, plenty of people doing on the technical side of things, and on the governance and regulation side of things. But I think you focus on more the social learning and cultural evolution side in your research.
I mean, that's the angle I've gone with, but actually, it's a kind of a philosophical difference to AI, which underpins the way I approach it compared to what the current zeitgeist is.
Mm-hmm.
So, at the moment, AI is sort of considered to be a mechanism for doing things and solving problems, whereas for a long time, AI was just, well, the main thrust of AI was it was a mechanism for understanding nature. It was a way of trying to understand intelligence by building intelligence.
Right.
So the idea was we have billions or millions of examples of animals. They all do these amazing, interesting things. They all have brains. They all have intelligence to some extent or another. If essentially all that's going on in a brain is computation and information transfer, can't we just do that in a computer?
Mm-hmm.
And by doing it in a computer, what do we learn about the nature of intelligence? And so a lot of the really key founders of AI weren't sitting there thinking, I can't wait to optimize business processes. They were philosophers and scientists of the most traditional type. They just wanted to answer the biggest questions and solve the biggest challenges. And to them, the biggest challenges was to create human-like intelligence as a way of trying to understand intelligence, as well as trying to use that intelligence for the benefit of society. And so my starting point with AI is always, how does this help me understand, nature or biology or evolution or intelligence? And because that's a big thing, I picked one domain, which was how can I understand the kind of the uses and utility of social learning and the emergence of culture and cultural evolution, which then feeds back into the application side eventually.
Sure.
But at the moment, we're probably lacking a lot of very public research into the foundations of AI. Yeah. And we're in a stage at the moment where we're sort of cannibalizing the theory that was done in the 80s and 90s with massive supercomputers.
Yeah.
And without really trying to do anything new or ask any new philosophical questions. So I think I'm a bit of a fossil, an AI fossil. Eventually, though, that'll come around and they'll need the fossils to come up with new theory to then drive forward the next wave of kind of AI progress.
So it does sound like you're going back to the principles of what AI was meant to be. Which is quite interesting because I've not heard that, but you are right that the technologists are sprinting ahead and trying to solve problems with AI. It's understanding what it is or should be. So what have you found in your research as kind of taught or what we learned from how AI is potentially related to humans or animals and how our brains and our intelligence works?
Well, none of the modern AI technologies are even analogous to animal intelligence in the way they work. But I think what we found is that you can do quite complicated things with very little. Humans are really good at looking at what they do and saying that must be the most complicated thing, without realizing that actually it probably isn't the most complicated thing. It just involves lots and lots of simple processes added up. Whereas some of the easy things that we do, like walking or like dealing with lots and lots of demands at the same time, is actually really, really hard. But because it's so ingrained into who we are and what we do, we don't think about it. Because some people find chess hard, we think chess is hard. But nobody finds walking difficult unless you have an impediment. So, and no one thinks, oh, that's because they're not good at walking. We say, well, it's because they've got an impediment. We kind of understand it. And so we think walking must be easy. But walking is hard. So I think what I've learned, or my perspective on it, is that you can't view intelligence as a single thing. It's the result of a process. It's a means to an end. Intelligence is a means to an end, and the end is survival and reproduction. Right. So ultimately, intelligence is the outcome of an evolutionary process. So unless you understand that evolutionary process, you never really understand the intelligence and what it was meant to do in the first place, or what problems it is trying to solve. And what we seem to be doing in AI at the moment is getting a big, massive hammer, which is massive amounts of computer power and data, and going, that will solve all the problems. But we don't really know what the problems humans are trying to solve are. So,
very true, yeah.
For the AGI community, artificial general intelligence, which I personally don't think is a thing, I think it's a bit of a nonsense. They keep finding new tasks to solve to show we are closer to super intelligence. I think the founder of OpenAI has claimed that the new ChatGPT version model has super intelligence. It's a pointless term.
Yeah.
AGI is a pointless term. It doesn't mean anything because they've just created more tasks to say, well, I've solved those tasks. Oh, well, I solved these tasks. And it's like, well, but why? Why are those tasks important? So the reason I take the perspective of evolution, so actually underpinning everything I do is I take an evolutionary approach to kind of artificial intelligence, is that evolution is fundamental to getting intelligence. You don't know what type of intelligence you're going to get out, because it's in response to the evolutionary pressures and the evolutionary journey when intelligence goes on. And so trying to create intelligences that are exactly like another animal is always going to fail, because you literally need to roll back their entire evolutionary history in order to get that outcome back out again. So maybe even stop worrying about what type of intelligences you're getting out with AI. Just don't worry. It's an artificial intelligence for a particular set of tasks or a particular scenario.
Yeah.
It doesn't matter if it's similar or not similar to a human or a dog or a chimpanzee. It doesn't matter. It just doesn't matter. What matters is it does what it needs to do, and you need to define that better.
Yeah, that's really interesting, actually. And I think you're probably right from my layman's perspective and the layman's understanding of it. But you're right. So I think the technologist, as you say, I think I saw the same quotation from Sam Altman to say there'll be AGI, or OpenAI will achieve AGI in 2025, I think. But obviously, his motivation may be more around raising money and staving off his competitors.
But it's easy to achieve a thing that doesn't have a hard definition that you get to define yourself. They'll achieve AGI as soon as it is useful for their stock prices for them to achieve AGI.
Exactly that. Okay, so if artificial general intelligence isn't a thing, what is AI then? How are we trying to mimic, or even, well, if there's no point to trying to mimic human or animal behavior in terms of intelligence? Is there any practical uses to AI outside of the evolutionary understanding of it?
Well, there's a lot of discussion there to have on definition, right?
Yeah.
So clearly AI is useful because we are using it and it is useful. Now it's up to you whether you define what we have as AI or not. And actually that's up to society to determine what they describe it as.
Mm-hmm.
I don't think we have a good definition of intelligence. So there's a professor over in Germany called Joanna Bryson. She used to be at Bath, and she has a really interesting kind of perspective on intelligence. It's just the ability, I hope I'm not misquoting her because otherwise she'll tell me off. It's just the ability for something to do the right thing. And so you could argue that a thermostat is intelligent because a thermostat is responding to external stimuli and producing the response that is based upon that stimuli. So you could argue that's intelligent if you wanted to. Now, that's not really what we mean.
No, it's not.
But then if we move away from this idea of kind of hard definitions or hard categories of things and move to kind of a continuum, if you look at kind of the animal kingdom, at what point along the continuum of animal intelligences do you start saying, well, that is what we really mean by intelligence there? So, is an ant intelligent? Well, one ant might not be, but many ants together are, because they have a kind of collective intelligence. But what about a virus? Is a virus intelligent? People would say no, but then
it mutates and it adapts, right?
Yeah, it mutates, it adapts, it survives, it spreads, as we all sadly saw during COVID. So that's not what you mean by AI, right? If we have a virus AI, well, that's not very interesting. So, okay, humans, they're intelligent. Let's start at the top, they're intelligent. Let's move down from humans. But even then, there's not a linear scale. Intelligent at what? If you measure a giraffe's intelligence by its ability to climb up a tree, it's going to look pretty stupid, but it's not what this intelligence is designed to do. So yes, AI is very useful, but it does very much depend on what you define as AI.
Yeah, so I mean, it's probably, especially in the animal kingdom, it's probably there's a fine line between intelligence and instinct, and where that instinct comes from, and where that's coded into its DNA, or whether it's learned behavior. Because you can say in the animal kingdom, certainly there's a lot of stuff that animals do instinctively, or we don't understand how they do them.
Yeah,
and it may look intelligent to us, but does the animal have the ability to reasonably understand why it's doing what it's doing?
Humans have a very, very narrow temporal window that we look at. So when we look at human intelligence, we're looking at, a maximum a couple 100,000 years, maybe even less than that. And in reality, we're looking at kind of the last kind of couple of decades. We even kind of write off what people did decades before,
Certainly.
The uncivilized or stupid kind of history. But in reality, that's just a blink in terms of evolutionary time. We don't know. There might be a very particular scenario where certain animals thrive in a way that we might write it off as instinct. That instinct might be the most intelligent thing in a certain scenario. Cockroaches are pretty intelligent under a nuclear holocaust, and it's got nothing to do with their cognitive capacity. It's got something to do with more than that. So there's also views that intelligence has to be embodied. So an intelligence can't be truly intelligent if it's not embodied within a body.
Yeah.
It has to control that body within an environment. There's some debate about what embodiment means. It has to be situated. So it needs to be situated in a context. It can't just be a floating intelligence and then you throw tasks at it. It has to be situated like a human is environmentally and socially situated. You will go outside today and you will have to survive with the weather, with other cars around, with other people, and you'll also have to deal with the kind of broader social context. You'll have to meet social expectations and requirements. So all your intelligence is guided towards being situated in an expected context. And if we take you out of that context, you might struggle.
Yeah.
If we put you in the Australian outback, you're going to struggle quite a lot. Because you've never experienced that before. There's another one as well. I've forgotten what the other one is. Embodiment, situatedness, and doesn't matter. There's another one. There's another term. But the idea really is that intelligence is more than just kind of solving a kind of package task. That actually it's about a broader temporal concept. So over time, and not over just the time of one intelligence, but many intelligences at the same time, and over very different contexts in terms of environmental context as well. So it's hard to judge intelligence without judging kind of spatial and temporal context as well, and which we don't do very well with AI because we have a task we want it to do, and then we have a whole set of other tasks that we want it to do, like a game show really. And it's hard to judge if something is genuinely intelligent or not without taking it out of that context and seeing, well, can it just adapt and survive in the world, whatever that world might be, without having predefining tasks. Those tasks being an emergent part of the world itself, which is what we do, which is what all animals do.
Yeah. So, like you did at the start, so your work does seem to bridge between the social sciences and the technology side in terms of AI. So I've not heard many of the social sciences in terms of the philosophy and the sociologists, etc., talk too much about AI. So you must be in that perfect little sweet spot to kind of bridge that gap. Do you get much resistance from your fellow colleagues in the social science side of academia?
So I'm a member of the Cultural and Evolutionary Society, which is a group of people who are interested in how culture evolves and changes over time. And that covers a lot of social scientists. And I am one of the few kind of non-social scientists in the room. And it's more a kind of a language barrier. Right. So they're more kind of confused about the way I view the world, because they've not had to consider it in that way, in the same way that I'm confused about what they're saying as well. So they'll be giving presentations about how children learn things. And I'm there giving a talk about, well, how AIs learn things. And they're just totally different things. They're the same words.
Yeah.
The learning is the same word, but the mechanisms underpinning it and the context are different. So you have to kind of discuss it more broad within a kind of a more precise subjective, what am I trying to do? And actually I'm just saying I'm trying to understand the same thing you're trying to understand. I'm just using a different medium. And actually in most social sciences, they're starting to consider AI as just an actor within social kind of contexts. So there's a thing called the dark internet. Is it the dark internet theory?
Yes.
The idea that on the internet there's more bots talking to each other than there are humans.
Yes.
Now, if there's bots talking to each other on the internet without really realizing that each other are bots, and they're doing online learning as well, so they're learning from the responses, that's an artificial culture developing, right? Yeah. That humans are then part of and influencing our culture too. So there's an appreciation, and that's an important part of how we as a society are going to, change over time, is through interactions with these kind of semi-autonomous artificial agents too.
Yeah, I did see, I think, one of these short little viral videos where someone just got two ChatGPT enabled phones and just started a conversation with them, and they started talking to each other. Yeah. And it was in a couple of minutes, I think they asked each other, are you AI? And they figured each other out. So I was like, whoa, that's pretty cool and pretty nifty that they did that. But just understanding how their model and the traditional AI technology model works is obviously it's just taking sources of data. It knows what the rules it's based on. It's a probabilistic model, and therefore a computer can figure that out with enough computational power fairly quickly.
Yeah, at the moment.
Yeah, at the moment. But then we would assume that that's intelligence, right? Because from an outside person, it looked like an intelligent conversation going on. If you read the transcript of it, it seemed like two people having a conversation.
Well, that's the key there, right? Intelligence is really in the eye of the beholder.
There we go.
So if something seems intelligent to you, then it's intelligent. And we might be imposing that intelligence on something, but it affects how we interact with it. So maybe having kind of hard definitions of intelligence isn't very useful, and it's much more useful to say, well, it looks intelligent to me, even if not a lot's going on underneath. We seem to think we need these big brains for intelligence, but some very simple creatures do some very intelligent things in some contexts.
Well, it's the other one. It reminds me of the double slit experiment, doesn't it? In terms of just by the nature of observing quarks or protons, atoms, or whatever that made
light. I think
light. There we go. It actually changes the nature of the behavior of the.
Quantum computation. Yeah.
So it's like
the quantum physics. Yeah.
So at that level, it's like, okay, so are they intelligent then? Are we living in the quantum world? Are we living in a multiverse? It kind of triggers all those questions, right?
Yes.
So I send you down another rabbit hole.
That's why you could do a PhD.
Yeah, unfortunately, I'm still strong with school, never mind university. So obviously, speaking of that, then obviously you've got a unique take on this. So what are the future directions of this area of study and kind of the evolutionary systems and how it's going to work with AI? How do you see kind of your society that you're a member of spawning and evolving in its own right?
So my home actually is a community called the Artificial Life Community. So it's kind of started in the 80s out of the Santa Fe Institute in America, and it's the idea that like if AI is trying to understand intelligence through building intelligence, well, artificial life is trying to build life to understand life. So the quote from Chris Langton, who was the founder of the field, is not life as it is, but life as it could have been. So the idea that if you roll a dice and it rolls a 1, you don't go, well, die, you always land on 1. No, you have to roll it multiple times. Well, Earth is just one roll of a dice.
True.
Very complex dice. Yeah. It's one roll of a dice. So why would you assume what we see would always happen? What things, when you apply an evolutionary process, come out regularly and what don't? How does life start? What kind of dynamics could you expect from evolution and life? So it's trying to shine a light on evolutionary dynamics from a computational perspective, in the same way AI is trying to shine light on intelligence through computational perspective. And so in that field, generally, it's just about trying to understand what evolution really is, what it really does, and what you get out from applying evolution in artificial contexts. So my real interest is trying to just filter into that field and trying to understand how evolution works, why it works, from a computational perspective. And my kind of particular area is cultural evolution. I argue that culture is a second evolutionary system, analogous but not the same as Darwinian biological evolution. And so you could argue humans have two evolutionary systems, or we're part of two evolutionary systems at the same time, one being created from the other. There's some arguments that human evolution has been kind of subsumed into cultural evolution as well, but there's debates about that. But then from an AI perspective, it's then trying to understand the implications of those kinds of things. If we were to apply evolution to AIs, what are the implications of that? Do we really want our AIs changing in the way we see kind of animal populations or viruses changing, or do we want them to be a fixed thing that do an expected thing? Do we need to have evolution for AI to work in contexts we don't understand? If you send populations of robots to Mars, to terraform Mars, you can build them to solve a problem, but you're not there to observe that problem and understand that problem.
No.
Whereas evolution is a process for trying to solve problems over time. So if you had a reproducing population of robots, and we can do robot reproduction, we can get robots to 3D print children robots. There's been projects on that.
Yeah.
Is that the kind of thing we're going to need if we're going to explore other planets or explore space or explore undersea? Do we need the ability for these robots to adapt over time? If you need to do that, you need to start understanding the nature of evolution, because you want it to succeed. So you need to apply evolution in a way that will or is most likely to succeed over time.
So are we talking there about applying evolutionary algorithms, for want of a better word, to AI models? So the future models that we're talking about, and if they implant them in robots or whatever it may be, or other beings, that there's a new evolutionary layer and coding that sits on top of the machine learning and the data learning side of AI?
Well, actually, we've been doing it since the 80s.
Oh, there we go.
It's just it. So everyone thinks machine learning is the thing, but in reality, that's kind of a path. There's kind of a splitting path between evolution or learning, and learning is the one that's taken off.
Yeah,
and evolution is the one that's kind of not been relegated. It's just it's harder to get evolution to do immediately successful things, targeted successful things. Whereas machine learning, you say, this is the data, this is the problem, learn, and it works. Plus it's much more satisfying in the short term, because you can see a very clear trajectory towards success when done well, and it's taken a lot of work by a lot of people to do it well. Where evolution computation, it's a lot less precise. You're not expecting it to be right.
Yeah.
You're expecting kind of the algorithm to go on a journey through space to find solutions. But there has been work over the last kind of 10, 15 years, well, actually for longer than that, but most successfully in the last 10, 15 years, about the integration of evolution to kind of machine learning models, to neural network models, in order to do less hand designing of the learning and allow the learning to emerge as an evolutionary property of the system. And there's been some work done by a guy called Ken Stanley, who used to work for Uber AI when Uber had their own AI roof, but he might work for OpenAI now, I'm not sure. Where he does a lot of neuroevolution, and he applies evolution to these machine learning systems, and he's outperformed some of the non-evolutionary models on things like Atari games, because there's lots of AI reinforcement learning models that play Atari games. They're playing really, really well, and he's shown that evolution can actually do slightly better if you kind of do evolution and learning. And that makes a lot of sense, because we are an example of something that has used evolution to develop the learning. The learning kind of works within lifetime. Evolution works between lifetimes. So evolution is tuning the learning over time. The learning is self-tuning itself within a lifetime as well. And it's kind of a feedback loop. And you kind of search for solutions in a slightly different way using evolution. which means you can get more novel solutions. You can take pathways you don't expect it to. So I think that, so my argument actually is that in the next kind of 20, 30 years, we're probably going to see the integration of evolution into current AI technologies in order to kind of find new and novel, different solutions to problems beyond what we've already found, open up kind of new pathways of investigation, allow our AIs to adapt a little bit more to dynamic scenarios. But that comes with whole other regulatory issues about how do you control that, or how do you regulate what it's doing? How do you regulate the change? Yeah, it's a complicated one.
Sounds like a very complex and exciting area anyway. Just some closing thoughts then. Obviously, I understand you're a big Villa fan. Do you see any cross-pollination between your work in evolution, cultural AI models and crossover to
Not my work.
passion?
Not my work, I'm afraid. Not my work. But I think we're in a Moneyball era of sport, aren't we?
Certainly are.
So I can definitely see AI being much more integrated into kind of every aspect of sport, from conditioning all the way through to tactics and game management.
Yeah, well, this is just to go on my own personal passion as well. I kind of, I'm a Liverpool fan. I kind of follow the Liverpool model of buying players, and they've probably got one of the best success rates, and they kind of use big data to kind of use their decision making business. But I've always kind of thought people get it a little bit wrong when they're trying to predict what will happen in a match. Based on the players that you put on the pitch and they have an XG or the least many forward progression passes or whatever the stats are that they use. But I've always gone, the variables are too high in that there's so many different variables, whether it's the weather, the opponents you're playing against, who playing on your team, fitness, blah, 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 blah.
The abuse you're getting from the sideline.
Exactly, and all that kind of jazz. But then I'm thinking, kind of was driving in about this conversation here today, I was like, actually, the computational power, and if you've got enough data points, it's all about probability, right?
Yeah.
So if you can actually go, if this player's in this situation against this opponent, you can probably run a model fairly quickly. Because the parameters for an AI model with enough computational power behind it isn't going to be that excessive compared to what they'd be used to doing. So I think you may find in the next maybe 3 to 5 years, you'll see live decision-making processes being made by AI models on the side. No one will ever reveal it. All it did be the case.
Or someone, on Match of the Day kind of superimposing what the model said they could have done, and then they went this way and they went that way. But it's quite, so as a side to that, it was really interesting when AlphaGo, which was an AI model for playing Go, which kind of implies, chess, but much more complicated. When it played the best Go players and beat them, there was a point, and they called it move, it might be move 47 or something. There was a particular move, but the AI model did something that made everybody stop because it made no sense.
Yeah.
And everyone was like, oh God, it's going to lose. That's a stupid move. And the professional player was just sort of so confused by it. It's like, that shouldn't happen. But the AI player went on to win, and they went on to study exactly why it made that decision. And they sort of can not really understand why it made that decision. But it's now become part of kind of how Go is played as a game. But that kind of move now happens because it's permeated through kind of the Go community. So there's this two-way cultural evolution.
Well, that's a fascinating one, because I've always thought that even when you see some of the tricks that AI can do in terms of video creation, text creation, whatever it may be, it's not innovating in its own right in terms of it's only recreating what's already been created. But if it's doing that and it's done something that no human's done before, you're right, it is an evolution.
But it's more that it's within a
set parameter.
Yeah, you've got set parameters in the game, and it's just that humans are we're not as clever as we think we are. And we do, we have lots of shortcuts to the way we think about the world because they give us good solutions most of the time. Whereas an AI doesn't need to worry about that. An AI just needs to worry about exploring that parameter space and finding the best solution. And so you could argue in the football context that if we start analysing these kind of things, it might be that AIs can find what look like strange kind of patterns of play in football that actually would be in the optimal approach if you didn't have such flawed and limited humans with their flawed and limited perspectives. And you never know, that might then feed back into the way football tactics work. It's be interesting.
go back to long ball.
I miss a bit of long ball.
Exactly. Well, James, thank you very much for your time. Just to kind of close, if somebody wanted to learn more about your work or wanted to kind of dip their toes into this field of themselves, where's the best place they could kind of learn from yourself or kind of follow your work?
So you can find me on Google Scholar. I have my own website, which is jmborg.com. No, I need to update it, so give me a bit of time. I'm part of the Aston Centre for AI Research and Application, and there's a whole bunch of us who do evolutionary-based research, as well as lots of machine learning researchers too. So we do some cool stuff. And you can also check out the Artificial Life Journal, which is the kind of my home journal, which is where I publish more often than not. It has some interesting stuff about evolution and AI and all those kinds of interesting things.
Cool. Well, fascinating conversation. I think my head's about to explode. But Dr. James Borg, thank you very much for your time.
Thank you for having me.